Hello everyone, welcome to MathFi. Today we'll be covering box plots. Box plot is a grade 6 topic in GCSE higher maths. What does box plot mean? It is a unique way of showing the 5 most important data depicted in this graph. So as you can see, our box plot ranges from minimum value to the maximum. To start off, the minimum value represents the lowest number in the data. Next, we have the lower quartile. Lower quartile means the median of the lower half of the data. In other words, this is the 25th percentile or 25%. Next is the median. Median is at the middle. Note that the median is not always at the middle of the box. It could be spread anywhere across the graph paper, depending on what the question is asking and depending on the type of data that are displayed either in a table or other information that might be quite useful. Next, we have the upper quartile. This is the median of the upper half of the data. In other words, 75th percentile or 75%. The easy way to work out the upper quartile is lower quartile multiplied by 3. That's the quickest way to work out the upper quartile. I'm coming back for the lower quartile. To work out this quartile, we need to half it from the median. That's also another useful way to work it out. And lastly, we have the maximum value. This is the maximum number in the data. One interesting variable that I would like to focus on is the interquartile range. Interquartile range can be worked out by subtracting the lower quartile from the upper quartile. In other words, interquartile range equals upper quartile minus lower quartile. Let us look at an example together. Below is the score achieved by 15 students in the mock exam. Here are the list of numbers. Notice that they are not in order. All the numbers are in different orders. For example, 75, 54, or here 52 to 64. We need to make sure that all the numbers are in order. So how do we do that? So we start from the smallest number to the biggest number. So from 52 to 75. That gives us hints that our minimum value would be 52 and our maximum value would be 75. How do we work out the median, the lower quartile and the upper quartile? But before we do that, there is something very important, and that is labeling the graph. Labeling the graph affects the accuracy of the results. If you can label the correct numbers properly, you will get the correct answers and it will show high levels of accuracy. So 45, 50, 55, 60, 65, 70, 75, 80. Why did I start off 45? Because our lowest number is 52. I allowed enough space just so that the data are spread beautifully and it's easily visible. So we know that there are 15 students that were scored in the mock exam. How do we work out the median? So a typical formula that I used to work out median, n plus 1 divided by 2. N would be 15, the number of students, plus 1, which is 16, And 16 divided by 2, which is 8. Therefore, 15 plus 1 divided by 2 equals 8. That 8 means the 8th number or the 8th position. So given that there are 15 numbers here, we need to work out the 8th position. 1, 2, 3, 4, 5, 6, 7, 8. The median is 60. Let us work out the upper quartile. Remember, upper quartile is the median of the upper half of the data. But before we do that, let us plot our median, which is 60. That's our first data done. For the upper quartile, as I mentioned earlier, we need to work out the median of the upper half of the data, which is represented by these numbers. So from 60 to 75. How do we do that? We can cross out. So 60, 75, 61. Ultimately, our upper quartile will be 64. How did we get that? So cross out 60, 75, 61, 70, 61, 67. That's our upper quartile. And we will plot our second data, the upper quartile. Next is the lower quartile. It's the same procedure as the upper quartile, but the only difference is we will need to work out the median for the lower half of the data. So you start from 52, 59, 54, 58, 54, 58. Therefore, the lower quartile will be 55. Let us plot our third data. Next, we draw lines together. So we have 3 data now. We are left with 2 that are needed to be plotted into the graph, and that are the minimum and maximum values. We already know the maximum value is 75, so we can plot that out. And we also know the minimum value, which is 52. But before we do that, we join them together. The same can be said for the minimum value. We know it's 52. And lastly, we just need to connect them together. And that is how you draw a box plot. Here is a typical exam style question. So the table shows some information about the math scores of year 11 students in the mock exam. Draw a box plot for this information. We don't need to label the graph as it's already been done for us. And also we are given 5 data. So for this question, all you need to do is plug in the data we know. The median, the upper quartile, the lower quartile, join them together. So as we can see, 60 is our upper quartile, the median is 48, and our lower quartile is 31. Maximum value is 75, we join them together. And lastly, our minimum value is 17. And join them together. And that is your answer to the exam style question. Here's another question to go through. So the table shows some information about the English scores of year 11 students mock. Here are the data displayed. Compare the distribution of the maths and English scores of students. So this box plot represents the English scores of year 11 students. In the previous slide, it was the math scores. How do we compare the distributions? We put them side by side, so it's easy to compare. When we look at comparing the distributions of the maths and English scores, we are looking at 2 important data. One is the median, and the other is the interquartile range. So to start off, we can see that the median of English scores are greater than the median of math scores. Why is that? The sole reason is because the median for the English score is 61, which is substantially greater than the median score for maths, which is at 48. So that's your first comparison. Your second comparison is the interquartile range. Now, when you work out interquartile range, you do upper quartile minus the lower quartile. So for the math scores, our upper quartile is 60, the lower quartile will be 31. The interquartile range therefore will be 60 minus 31, which is equal to 29. That's the interquartile range. Let's do the same for English scores. The upper quartile is at around 74 and the lower quartile is at 43. So 74 minus 43 equals 31. What can we imply about these scores? We can say that the interquartile range of English scores are greater than the interquartile range of math scores. And that is your second comparison for the distribution of maths and English scores.